So to solve modulus inequalities, you first should know how to solve modulus equations. And once you know how to do those, there are two methods you can do to solve modulus inequalities. The first one is just like taking the inequality and writing the inequality but turning it into an equation. So you don't have the greater than or less than, you just have the equal sign. And then you solve this equation. You should know how to solve these. Let's say your answer is x equals -1 and 4, for example. Then you have to write a sign diagram to find the intervals for when the inequality is satisfied. And then you test values for each interval. Let's say like this one works, this one doesn't, this one works. Then you know which intervals satisfy the inequality, this one and this one. And you just write those down. And the second method you can use is to write the inequality into two inequalities, similar to how you solve modulus equations. So let's take this inequality, and the first one we're going to do is for when f of x is greater than 0. And, that works for when f of x is greater or equal to 0, or when it's positive. And the second one is when f of x is less than 0 or negative. And we flip the sign around and turn g of x negative. And this is when f of x is less than or equal to 0. And now you solve both of these inequalities, and you should know how to solve these. And remember, once you get your solutions, make sure it matches up with like the conditions that you set for each one, for the positive and negative, and then you have your answers. So now let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one has to solve the inequality absolute value of 2x minus 1 is less than 4. And you can do either method for this one, but for this one, I'm going to do the one where you split it into two inequalities. The first one being 2x minus 1 is less than 4. And remember, you have to set your condition 2x minus 1 is greater than or equal to 0. So this is our one where it's positive. And we have to simplify this inequality. And this simplifies to x is greater than or equal to 1/2. And then the second inequality is 2x minus 1. Flip the sign so it's greater than -4 because we changed the sign of the right side. And again, we have to write our condition. 2x minus 1 is less than or equal to 0, so when it's negative. And again, we can simplify this to x is less than or equal to 1/2. So now we have to solve both inequalities. This one becomes 2x is less than 5, or x is less than 5/2. This one becomes 2x is greater than -3, or x is greater than -3/2. So now we have both of our solutions to the inequalities, and then we have to match them up with the conditions that we set. So the first one, x is less than 5/2, and x is greater than or equal to 1/2. So this becomes 1/2 is less than or equal to x is less than 5/2. And then the second one, when x is less than or equal to 1/2 and x is greater than -3/2, this becomes -3/2 is less than x is less than or equal to 1/2. So now we have both of our inequalities, and then we just need to combine them. And you notice that both of them stop at 1/2, and x is able to equal 1/2, so you can just combine these into one, and it becomes -3/2 is less than x is less than 5/2. And that's your final answer. And now let's do another practice problem. If you think you know how to do this one, pause the video and try it. This one says solve the inequality absolute value of x plus 1 is less than absolute value of 2x plus 3. And for this one, it will be easier to first write the corresponding equation like this, and then decompose it into multiple different other equations, because we have a modulus on both sides. So first, let's write two equations and let's get rid of the absolute value on this side. So first, 2x plus 3 equals absolute value of x plus 1. Keep it the same. And 2x plus 3 is equal to negative absolute value of x plus 1. But we can just move this negative to this side to make it easier. And then now we have to do it again, decompose both into two more equations. So this one turns into x plus 1 equals 2x plus 3, and x plus 1 equals negative 2x plus 3. This one turns into x plus 1 equals negative 2x minus 3. Or this is also negative 2x minus 3. And x plus 1 is equal to 2x plus 3. And notice that both of these are the same. And when you have modulus on both sides, I think this is going to happen every single time. You're just going to end up with only two equations. But I just wanted to show that so you understand how the process works. And now we just have these two equations to solve. So first, let's solve x plus 1 equals 2x plus 3. That's negative x equals 2, or x equals negative 2. And then for this one, it turns into 3x equals negative 4, or x equals negative 4 thirds. So we have both of our potential solutions, and we need to plug them back into the original inequality to check if they work. So let's try x equals negative 2 first. Absolute value of negative 2 plus 1 is less, or is equal to absolute value of 2 times negative 2 plus 3. And this becomes 1 equals negative 4 plus 3, 1. So yeah, this works. And so x equals negative 2 is a solution. And let's try x is equal to negative 4 thirds next. So negative 4 thirds plus 1 equals absolute value of 2 times negative 4 thirds plus 3. This turns into absolute value of negative 1 third equals 2 times, or negative 8 thirds plus 3, which is just 1 third. And these are equivalent, so this means both solutions work. So now that we have both solutions, and right now I'm going to erase the work done to prove that they're both solutions, but if you're doing this on homework or a test, you shouldn't do that because I don't have enough room. So now we need to write a sign diagram with points at both of our solutions, one at negative 2 and one at negative 4 thirds, and check if the inequality works for all of these intervals. So let's try negative 3 for this region. So negative 3 plugging into the original equality is absolute value of negative 2 less than absolute value of negative 6 plus 3. And this becomes 2 is less than 3, which works. So yes, this region works. Let's try this middle. Let's try negative 5 thirds. So absolute value of negative 5 thirds plus 1 is less than absolute value of 2 times negative 5 thirds plus 3. This becomes 2 thirds is less than absolute value of negative 10 thirds plus 3, which becomes 1 third. And this is not true, which means that this region in the middle does not work. And let's try this region now. So let's try 0 for that. Absolute value of 0 plus 1 is less than 2 times 0 plus 3, which becomes 1 is less than 3, and that's true. So yes, this region works as well. And now we have the parts where the inequality is satisfied. So x is less than negative 2, or x is greater than negative 4 thirds. And those are your two inequalities that satisfy the inequality, and that's your final answer. So everything that I explained in this video and all the problems that I went through to teach you everything you need to know about solving modulus inequalities. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.